All right, so let's put this in another example. We have two archers, Lee with a probability of 3/4 of hitting a target and Yuka with a probability of 4/5 of hitting a target. Both shot simultaneously, so they shot at the same time. Draw a tree diagram and determine the probability of only one person hitting their target. So very similar to the coin flipping that we're looking for only one person to hit, and therefore the other person would have to miss. So I'm first going to draw a diagram for Lee. So Lee is going to come up first. So Lee has two options. They either hit, I'm just going to say H, or they miss. If they hit, they have 3/4 probability of hitting the target. So either 3/4, or if you'd rather use the decimal of 0.75, that's fine. Which means they have, this is where complementary events come in, they have 1/4 probability of missing the target, right? Because I know it's either a hit or a miss. Those are the only two options. So 1 minus that 3/4 gets me the miss. Next, I'm going to put in Yuka's information. So again, Yuka can either hit or miss. But again, we're going to put that in twice, one for if Lee hits and one for if Lee misses. So Yuka's probability of hitting the target is 4/5, which means her probability of missing the target is 1/5. And I'm going to repeat those same probabilities down here. So now when I go to look at the probability of only one person hitting the target, again, very similar to the coin flipping, I'm looking for one person hits and one person misses. So maybe Lee hits and Yuka misses. So I'll look at this branch. 3/4 times 1/5 would get me 3/20. Or the decimal equivalent of 0.15. Again, either one is fine. Decimal or fraction, but not percentage. On the flip side, Lee could miss and Yuka could hit. So 1/4 times 4/5 could be 4/20. I could simplify that, but knowing what's coming, I'm going to leave it. Or the decimal equivalent of 0.2. And so again, since we're looking at multiple branches here for our probability, we're going to take those individual branch probabilities and we're going to add them up. So that's why I kept it as the 4/20, so I could easily add this up to be 7/20 or 0.35. So there's a 7/20 chance or a 0.35 chance that only one will hit the target. All right, in example 2, a box contains 3 red, 2 blue, and 1 yellow marble. Find the probability of getting 2 marbles of the same color if, and this is a 2-part question. Part A is if replacement occurs, meaning when I pick the first marble, I note the color and I put it back. So let's start drawing our tree diagram. First, I have 3 different possibilities this time. I have a red, a blue, and a yellow. I have a total of 6 marbles, so that means the probability of getting a red is 3/6, or 1/2 is fine. Probability of getting a blue marble is 1/6, and the probability of getting a yellow marble, 2/6. The probability of getting a yellow marble is 1/6. And since replacement's occurring, that second draw will be the exact same probabilities. So I'm going to take this same branch and I'm going to repeat it for the red if it was drawn first, the blue if it was drawn first, and the yellow if it was drawn first. All right, so again, that same 3-branched diagram for the red, the blue, and the yellow. So now we're looking to see the probability of getting 2 marbles of the same color. So that could mean 2 reds. So I'll look at this top branch. That could mean 2 blues. So I'll look at this branch in the middle. Or it could mean 2 yellows. So the branch at the end. So 2 reds probability, 3/6 times 3/6 would be, I'm not even going to do it. I'm just going to write it out. I can do it all on my calculator at the end. Oops. 6. My blue branch would be 2/6 times 2/6. And again, you can simplify these 1/2 times 1/2, 1/3 times 1/3, and my yellow 1/6 times 1/6. And then again, I'm going to take all three of those and I'm just going to add them up. So all three of those products added up means I'm looking at a probability of 7 out of 18, or the decimal equivalent of 0.389 to 3 sig figs, either way. So multiply along your branches, add up all the different possibilities. All right, part B of this is the exact same setup, but we're saying that replacement does not occur this time. So that means whatever I pick first, I keep it out and then draw the second one. So those probabilities in the second set of branches are going to change. The first set will be the exact same though. So again, my first set's the same as it was when replacement was occurring. And now when I go into my second pull, it's going to be different, because now when I pull this second red marble, or if the possibility if I pull that second red marble, not only is my sample space only or my possibilities down to 5, but if I pulled that red marble first, that means there's now only 2 red marbles left. So the probability of drawing a second red marble is only 2 out of 5. My probability of pulling a blue marble, this first one, we're saying from this branch that I pulled a red marble. So that means those 2 blue marbles are still there, but it's still decreased down to 5 marbles in the bag in general. Similarly with the yellow marble, that again, there's only 5 marbles to choose from now, and I didn't pick the 1 yellow marble, so that can still be a 1. When I go to do my blue, and I know it's getting a little, I'm gonna have to type these in because it's getting a little crazy in here. So from my blue marble, I'm going to start with my blue in my second pull of probabilities. Just like my red, both my numerator and my denominator will decrease by 1. I already pulled one of the 2 blue marbles, so I'm only down to 1 left. And again, I kept it out, so that means I only have 5 marbles left in the bag. When I go to look at my probability of pulling a red marble second, I'm only pulling out of 5 total marbles, but that 1 that I pulled wasn't a red, so there's still 3 reds left. For my yellow, it will be the exact same probability as when I pulled the red. I'm only looking out of 5, and there's still 1 of the 5 is yellow. Finally, with my yellow opportunity, or my yellow marble, I'm just going to do it this way. I'll start with yellow. Just like the other 2 branches, I'm down to 5 total marbles that I'm pulling from. However, I only started with 1 yellow. So when I pull that out and I keep it out, that means I have no yellow marbles left to pull. My blue and my red, I can actually use pieces from the other 2 branches that I've done. With my blue marble, again, we know that both of them are going to be out of 5 because I only have 5 left. My blue marble, I still have the 2 blues left. So just like my very top branch, I'll have 2 out of 5 left. With my red, I'll still have all 3 left. So just like my middle piece, I'll have 3 out of 5 chance of pulling it. All right, so I cleaned this up a little bit, and now we're looking still at the probability of getting 2 marbles of the same color. So I'll still look along my red branch of 3/6 times 2/5. I'll still look around look at my 2 blue branches, 2/6 times 1/5. And I'll still look along my 2 yellow branches, 1/6 times 0/5, or just 0, either way. And I'm still going to multiply those values and then add up all 3 products. And when I do that, I get 4/15, or 0.267 as a decimal. All right, so moral of the story with tree diagrams is once you have it set up, you're multiplying along your branches and then you're adding any kind of multiple possibilities that you have. And remember to use the complement. If you have to fill in things, maybe they don't give you all of the information in the beginning, use that complement to figure out any kind of missing pieces that you might have.